Alright guys, so here we are, Unit 3. This is Part B. Remember, Unit 3 is our huge unit. Then we are going to look at the different ways to solve a quadratic equation. Alright, so first I just started with some notes up here at the top. When you're solving the quadratic, basically all you're doing is finding the values of x. Remember that the exponent tells us how many solutions we have. So on most of these, we're going to have at least two. When we graph them, the solutions end up being the x-intercepts, which are also called zeros and roots. And there's three ways to solve quadratic. All right, so solving by factoring, we already went through this in the last video. So you need to start in standard form, factor completely, and then set each factor equal to 0 and then solve, and that will get you your solutions. So let's see if we can zoom in a little bit, make sure that's focused. All right, very good. All right, so first thing we need to do is we need to get this equal to 0. So I need to bring the 48 over here. So we have x squared plus 8x minus 48 equals 0. So this is a trinomial. There's no GCF. So we need to break this into two sets of parentheses. We need factors of negative 48 that add up to 8. So I'm thinking a positive 12 with a negative 4. So now we know that x plus 12 must equal 0, or x minus 4 must equal 0. So our solutions are negative 12 or positive 4. All right, on this one, first it's already set equal to 0, so now we're going to factor completely. There should be a GCF here of 2x. So if we take out a 2x, we will have 2x squared minus 13x plus 15 equals 0. This is a trinomial. We have a leading coefficient. So I'm going to go over here. We need to multiply and get 30, but our factors need to add up to negative 13. So right away I'm thinking 10 and 3. So we'll need a negative 10 and a negative 3. So we have 2x squared minus 10x minus 3x plus 15. And then we can't forget about the 2x from the front. All right, I'm going to group them just like that. So out of this group, I'm going to take a 2x, which would leave x minus 5. Out of this group, I'm going to take a negative 3, which will leave x minus 5. And then again, don't forget about the 2x out here. So now we have the 2x out front. We have x minus 5 as one of our factors, and 2x minus 3 as one of our factors. So now this is where we need to go through and set each one equal to 0. I've completely run out of space. So I'm going to go right up here. So if we set this one equal to 0, then x will equal 0. If we set this one equal to 0, we would need to add 5 to both sides. And if we set this equal to 0, we would need to add 3 and then divide by 2. So those are our solutions, 0, 5, and 1.5. And we could tell right here that we should have had 3 solutions, so that makes sense. All right, next up, completing the square. So completing the square, first thing we're going to do is move our constant term to the other side, because what we need is that perfect number right here. And we know that 10 is not that perfect number. It's not even a perfect square. So we need to move that out of the way. So x squared minus 8x plus blank equals negative 10 plus blank. Now I know I can figure out what goes here because I need half of this number squared. So half of negative 8 would be negative 4. Squared would be 16. So I'm going to fill in 16 to both sides because you know whatever you add to one side you have to add the other. So now this would get factored to be x minus 4 squared. which was the whole idea. And over here, this equals 6. So now I want to solve for x. Excuse me. So I'm going to take the square root of both sides. So the square root of x minus 4 squared is going to be x minus 4. And then whenever we take the square root, remember there's always the possibility of a positive or negative. And this is also where we're going to get our two solutions from, because we should get two answers. So now, to solve for x, I need to add 4 to both sides. So my solutions would be 4 plus the square root of 6 and 4 minus the square root of 6. But we can leave our answer right there. Now, the one problem with completing the square is if your middle coefficient is odd, you're going to end up with fractions. So I put, it's not ideal if the middle term has an odd coefficient. So just keep that in mind. All right, number 4. So the 24 is already off to the other side. There is a 2 out here. I need to get rid of this leading coefficient because when we do completing the square, we just want x squared. So I'm going to take a 2 out, which would leave x squared plus 4x plus blank equals 24 plus blank. All right, so basically I needed to get rid of this leading coefficient because that's going to get in my way of what half of this number is. All right, so now to fill in the blank, half of 4 would be 2, squared would be 4, so I'm going to fill in 4 right here. But before I go over here and fill in 4, it's really not a 4, it's actually an 8 that I need to fill in on the other side. So this can be factored as x plus 2 squared. Don't forget the 2 that's out in front. If we add this together, that would equal 32. Now we have to solve for x. So first thing I'm going to do is divide both sides by 2 to cancel that. So now x plus 2 squared equals 16. If I take the square root of x plus 2 squared, I'll get x plus 2. And then the square root of 16, don't forget it's plus or minus, but I also know that that is 4. So now I'm going to solve for x. I'm going to subtract 2 from both sides. So x is going to be negative 2 plus 4 and negative 2 minus 4. And I can actually answer this. So my solutions are, if I do negative 2 plus 4, I get 2 as one answer. If I do negative 2 minus 4, I get negative 6 as the other answer. All right, moving right along. Hopefully we can get this video finished. So, next is Quadratic Formula. This is the one we sang. I'm not singing the song, but this was the one it went to, like the Are You Sleeping or Frere Jacques, whatever, all that, the music stuff. I don't do the music thing. So, anyways, but this is Quadratic Formula. I would like to think that you probably already have it memorized. I'm not sure if it would be one that's on the formula sheet, but it very well could be. So we'll just have to see once we get the testing information if that's one that you need to memorize. But basically, when we go over here, we have to get it in standard form. So 2x squared plus 3x minus 5. So we have to have standard form. Once we do that, this is the value of a, right there. That is the b, and that is the c. So now we're just going to fill in. So we need negative b, which would be negative 3, plus or minus square root, b squared, which would be 9, and then minus 4 times a times c. So however you want to think of this, this is a negative 4 times 2, which would be negative 8, times negative 5 would be a positive 40. And then all of that is over 2a, which is 4. All right, so now we're just going to simplify. So this looks like negative 3 plus or minus the square root of 49 over 4. But that means negative 3 plus or minus 7 over 4. So now we can work this one out. If we do negative 3 plus 7, that would be 4 over 4 is 1. If we do negative 3 minus 7, that would be negative 10 over 4 can reduce to be negative 5 halves, which would be negative 2.5. So that's your solution. All right, next up, this one. If we move this over, we have x squared. We need to subtract 4 from both sides, so that's going to be plus 7 equals 0. So the reason why I did this example is because this is the A and this is the C. So what that tells me, there's no middle term, which means B is equal to 0. So just watching the time on the video, I'm not going to finish this one, but if we fill in what we know, negative B is 0. So then we have plus or minus the square root of B squared, which would be 0, minus 4 times A times C. So that's negative 4 times 1 times 7, which is negative 28. And all of that is over 2A, which is 2. All right, so I'm just going to move on to the next section, which addresses some of that anyways. The discriminant. The discriminant is B squared minus 4AC, which you should recognize that that is what's inside the square root. When we do the discriminant, we're not using the square root though. So remember that it's just the B squared minus 4AC. So you're figuring out what number would be inside the square root. And what it does is it tells you what kind of solutions you're going to have. Because if this is positive, then you're going to have the square root of a positive number, which means you're going to have two real solutions. Now, they could be like this, or they could be like this. But they would be real solutions because the answer in the square root is positive. All right? If your answer inside the square root is a negative number, that tells you you're going to have imaginary solutions. That's because, just like over here in this example, we're trying to take the square root of a negative number. And that's not a number, or there is no answer for that in our real number system. So this would be an imaginary solution. All right, the third thing that could happen is that what you get inside the square root is equal to 0, and in that case you'll only have one solution. And the reason for that is that you would have negative B plus or minus 0. So whether you do negative B plus 0 or negative B minus 0, it's not going to make any difference. So you'll end up with just one answer. All right, so this example asks us to find the value of the discriminant and then determine the number and nature of the roots. So that means how many, what kind. All right, so all we're doing is the B squared minus 4AC. So B squared is 4, and then minus 4 times 2 times 5. So negative 4 times 2 times 5 is negative 40. So the answer to our discriminant is negative 36. Since we got a negative answer, we know that there will be two imaginary solutions. All right, it looks like our time is just about up, and I think I'm not going to get to finish this example, but I'm going to go ahead and start it, and if it cuts off, it cuts off. So for this one, B squared would be 16, and then minus 4 times 1 times negative 3 would be plus 12. So that equals 28. So that means we will have two real solutions. All right, that takes care of Unit 3B.